Today, we're completely demystifying the terminology of triangles. If you've ever mixed up the names of these shapes or honestly just wanted a clear, perfectly organized way to remember how they all work, well, you're in exactly the right place. Step by step, we're going to decode these shapes, so let's get right to it.
Okay, let's dive into this. Before we start categorizing anything, we absolutely have to establish the golden, universal rule of all triangles. Any shape with 3 sides and 3 angles has to follow this one specific law. The 3 angles inside the triangle will always, without fail, add up to exactly 180 degrees. Keep that number firmly in your mind. This 180-degree rule is literally the anchor for everything else we're going to explore today.
Section 1. Classifying triangles by sides. The 3-2-none rule. Let's head into this first wing of the house, where we categorize triangles strictly by the number of equal sides they have.
Starting right at the top with the number 3, we have the equilateral triangle. The formal definition here is 3 equal sides and 3 equal angles. And if you look closely at the word itself, lateral literally means side. So put it together, and equilateral translates perfectly to equal sides. Now, because all 3 sides are perfectly equal, all 3 inside angles are equal too. And since they always have to share that 180 degrees we just talked about, every single angle in an equilateral triangle is always exactly 60 degrees. Make sense?
Moving down our list from 3 to 2, we hit the isosceles triangle. This one has exactly 2 equal sides and, because of that, 2 equal angles. I absolutely love the origin of this word. Isosceles actually means equal legs. Think about it. How many legs do we have? 2. So it makes total logical sense that an isosceles triangle is the one with exactly 2 equal legs or sides.
Now, what's really interesting here is a brilliant visual trick baked right into the word itself. Isosceles can be super tricky to spell, but just look at the first 3 letters, S-O-S. We can use this as a fantastic little memory tool. Those letters stand for 2 equal sides joined by an odd side. It's this perfect visual summary built straight into the spelling. You're never going to misspell it or forget its definition again.
Finally, we hit the bottom of our 3-2-none rule, 0 equal sides. And that gives us the scalene triangle. The definition is pretty blunt, absolutely no equal sides, which also means absolutely no equal angles. Every single side is a completely different length. Actually, the word scalene means uneven or odd, which is literally the perfect name for a shape where nothing matches and the whole thing is just completely uneven.
Now, if you want an amazing way to lock all 3 of these into your memory, look at this fantastic coincidence. Let's arrange our 3 names in alphabetical order. E for equilateral, I for isosceles, S for scalene. Alphabetically, they're first, second, and third. Now check out the equal sides. 3, 2, and 0. The alphabetical order forms a perfect countdown of the equal sides. It's just one of those beautiful little math patterns that makes organizing this stuff so incredibly satisfying.
Section 2. Classifying triangles by angles. The 90-degree benchmark. Now we're shifting focus to the inside angles. So instead of looking at the outside edges, we're zooming in on the inside corners. And the absolute crucial point here is how these inside angles relate to a strict 90-degree benchmark. Let's break down the 3 possibilities. First up, if every single angle inside the triangle is less than 90 degrees, it's called acute. Second, if the triangle has exactly one angle that hits that 90-degree mark perfectly, well, we call that a right triangle. And third, if it has an angle that stretches way out and is more than 90 degrees, it earns the title obtuse triangle. It's honestly incredibly straightforward when you use 90 degrees as your anchor.
Section 3. Combining the names, first name plus last name. Let's see how all of this builds together. In the real world of geometry, triangles obviously have both sides and angles, which means they can actually hold 2 names at the exact same time, kind of like having a first name and a last name. Let's look at how this synthesis works. On one side, we have a property taken straight from our angle category, right, meaning the shape possesses a 90-degree angle. On the other side, we pull a property from our side category, isosceles, meaning it has 2 equal sides and therefore 2 equal angles. So what happens when a single triangle meets both of these exact criteria?
They merge to create a right isosceles triangle. And this brilliantly illustrates how you can instantly understand complex-sounding math terms just by breaking them down into their 2 core building blocks. When you hear right isosceles, you absolutely don't need to panic. You just read the words in your head. Right tells you there's a 90-degree angle. Isosceles tells you there are 2 equal angles. Put them together and boom, you have a complete, perfectly clear picture of the shape right in front of you.
Which brings us to our final challenge for today. If a right isosceles triangle has one 90-degree angle,
And we know it also has two equal angles. Can you guess what those equal angles actually are? Think all the way back to the very first rule we learned today. All triangles must add up to exactly 180 degrees, right? So if 90 degrees are already taken up by that right angle, how do you equally split what's left? I'm going to let you solve that little mystery yourself.